Okay, so for our first couple up here, taking improper fractions into mixed numbers. Number 1, what'd you get? 3 3/5. Good. Number 2, what'd you get? 5 1/4. Good. The next couple, changing them from mixed numbers into improper fractions. Number 3 becomes 17/3. 4, 17/6. And then reducing, number 5 reduces to 3/5. Number 6, 4/5. Good. And then converting 3/4 becomes how many 30 seconds? 24, and 1/3 becomes 5/15. Any questions on those? Okay. You had some homework from last Friday. Any questions on those you want me to go over? There was something there about factoring, and I'd asked you to hold off on that. We'll cover factoring later on in the course. Okay. Way back on the first day, last Tuesday, we had looked at something like this. 1/3 plus 2/5. Now we'd said we couldn't add that the way it's written because they have different names. And when we add numbers, we have to have the same name. So today what we need to figure out in order to add these is, first of all, what name do we have to change them to, and then getting them to that name. We already know how to change the name. We just need to figure out what name it's got to become. So I'm going to write these vertically just because I tend to add vertically. Seems to work best for me. However it works for you is fine. But we need to figure out what are we going to rename these to. Now some of you might be able to look at the thirds and fifths and be able to tell me that the common denominator is what? 15. Good. There are several methods of finding a common denominator. One of them, you just multiply them together. 3 times 5 is 15. In this case, that's also the smallest common denominator. Now, you've always been told that you have to find the least common denominator. And while that's the easiest one to use, you don't have to use that one. You could use a bigger one. We could use 30 or 45 or 60 here, and we're still going to get the right answer. It's just going to be more work because, 1, we have to work with larger numbers, and 2, we have to reduce it when we're done. And I'd rather avoid those if we can. So you can just multiply them together to get a common denominator. The other thing you can do is you can make lists. You got 3 and 5 are my 2 denominators. If I count up by 3s, it's 3, 6, 9, 12, 15, 18, and so on. If I count up by 5s, it's 5, 10, 15. There's my match right there, 15. There are other more complex methods of doing it. If we were going to get into algebraic fractions in here, I would cover some of those more difficult methods of finding them. Since we're going to stick with numbers, we're just going to make lists if you have to. For the most part, most of you guys can look at these and come up with the common denominator without having to do a whole lot. So back here, we're changing 1/3 into 15ths. What did we multiply 3 by to turn it into 15? 5. So what do we have to do to the 1? Times 5. So 1 times 5 is 5. What do we have to do to the 5 to turn it into a 15? Times 3. So what do you do to the 2? Times 3. So that becomes a 6. And now remember, when we add, we combine the counts and we keep the same name. So we're going to combine 5 and 6 make 11, and over we keep the same name of 15. 11/15. Any questions? Now I'm not going to spend any more time on simple fractions for addition. I'm going to jump right up to mixed numbers. If I have something like 8 2/3 plus 5 1/4. I need to find what is my common denominator going to be. 12, good. Now, a lot of books don't have you rewrite the whole number when they find that common denominator. I always do, because I found if I just rewrite the fraction over here, sometimes I forget to go back and do the whole numbers. So by rewriting it, it puts it over there where I can't forget about it. Again, however it works for you is fine by me. What do we do to the 3 to turn it into a 12? Times 4. So 2 times 4 is 8. What has to go up here? 3. It was 4 times 3 to make 12, so 1 times 3 makes 3. Now you'll notice here I have the fraction just put right at the end of the numbers, and it's lined up almost like it's just the last digit of the number. Because that's actually exactly what it is. It's just the last digit of the number. So just like any other addition, we're going to start on the right and work our way back to the left. 8 twelfths plus 3 twelfths is 11 twelfths. Then 8 and 15 make 13. So 3 carry the 1. Now, if you haven't figured it out by now, it never stays that easy. We got to go next step, which will look something like this. 7 3/4 plus 8 5/6. What's my common denominator going to be? 24 will work, but there's a smaller one. 12 will work. So what's going to go up here? 9, and then down here, 10. So we can go ahead and add 9 twelfths, but 10 plus 10 twelfths is 19 twelfths. Now that, we see an issue, that can be reduced to, perfect. So we're going to carry the 1, we're going to keep the 7 twelfths. Just like we would any other addition, we can carry. 1 and 7 combine to make 8, plus 8 is 16, so 6 carry the 1. Now you had said 20, somebody said 24 there. Would this have worked if we had done 24? Well, sure. This would be 18, this would be 20. That would add up to give us 38 over 24, which would be 1, carry the 1, and 14 24ths. 16 and 14 24ths. The 14 24ths can be divided by 2, give us 7 12ths. We get to the same spot. Like I said, the only two things is we have to work with bigger numbers, and then we have to reduce when we have to remember to reduce when we're done. But you can always just multiply them together to get a common denominator if you're stumped. So have you guys try one in your notes. 48 and 7/8 plus 36 and 5/12. I'll pause the recording and give you guys a minute. What'd you get for common denominator? 24 works, yes. If you had multiplied them together, you'd end up with 98 or 96, which would work, but it's kind of a big one. What goes up here? 21, and here?
31.
Careful. 10, right? You're getting a step ahead of us there. So we had 21 and 10 does make 31 24ths, which splits up to be 1 and 7 24ths. So we will keep the 7 24ths and carry the 1. So you got 1 and 8 makes 9, plus 6 is 15, so 5 carry the 1. 1 and 4 is 5, plus 3 is 8. So 85 and 7 24ths. How many of you had that? Good. Subtraction, we're going to skip right up to just subtracting with mixed numbers. Like 8 and 2/3 minus 5 and 1/8. Just like addition, we've mentioned before, subtraction, you have to have the same name. So between my 3 and 8, what is my common denominator going to be? 24. What's going to go up here? 16, and down here? 3. Good. Now we still work on the right, start at the right and work our way back to the left. We're just subtracting now as we go. So we have 16 minus 13 is, or 16 minus 3 is 13, and it stays 24. 8 minus 5 is 3. Simple enough, right? Okay, good. Well, then we're ready to move on to the next level of that. Like 9 1/3 minus 5 3/4. First thing, again, is common denominator, which is going to be what? 12 will be your common denominator. What's going to go up here? 4, and down here? 9. We go to subtract here. 4 minus 9 gives us a problem. So what are we going to have to do? We're going to have to borrow. So we borrow from this 9 and it becomes an 8. Now we're used to just putting a 1 in front of this here, but we can't do that here because what we borrowed is one whole object. And one whole object isn't necessarily worth 10 here. So what we have to do is we have to look at the denominator. That's 12. So what that is telling us is that one whole object we borrowed had 12 pieces in it. So we're adding 12 to our numerator. 4 plus 12 is 16 12ths. Now I'm going to pause there. Any question on where that 16 12ths came from? It's just because we have to add it's the denominator that tells us how much we've borrowed. So 16 minus 9 is 7 12ths. 8 minus 5 is 3. We're going to look at one more of those. Here, 12 1/6 minus 9 4/5. What is my common denominator going to be? 30. Nothing smaller. What goes up here? 5, and here? 24. So now I go to subtract. 5 minus 24, of course, is an issue. So we're going to borrow from the 2, make that a 1. What are we going to do here? Add 30. We have to add the denominator. 5 plus 30 is 35 30ths now. Now we can subtract. 35 minus 24? 11 30ths. Now, of course, 1 minus 9, I got to borrow. That's a 0, and that's 11. 11 minus 9 is 2. Okay, I'm going to have you guys try one. (42 1/2) minus 28 3/7. What do we get for common denominator?
14.
14. Up here? 7 down here. Go to subtract. 1/14. Didn't even have to borrow there. I screwed that up, didn't I? So 14 1/14. How many of you came up with that? Okay. Multiplication. Actually, I'm going to do this. I'm going to do 2/5 times 3/4. When we multiply, we do not need the same name, so we don't have to look for common denominators. Also, when we multiply, we combine the counts, so that would be 2 times 3, giving us 6, but we also combine the names, so that'd be 5 times 4 makes 20. Looking at that, what do we see that we can do? We can reduce both of those by what? 2. So 6 divided by 2 is 3. 20 divided by 2 is 10. We get 3/10. Now some of you might be looking at our original problem and asking, well, why didn't he cross cancel, or sometimes called cross multiply? Others might be looking at that right about now wondering what's cross canceling. Well, We look at this and we see that this is going to become 2 times 3 over 5 times 4. And looking at it that way, we see that we could reduce the 2 and the 4. So before we even multiply, we can reduce those numbers. 2 and 4 both divide by 2, give me 1 and 2. So if I did that up here, reduce my 2 and the 4, divide by 2, give me 1 and 2. So now I have 1 times 3 is 3, 5 times 2 is 10. I've reduced it before I multiplied. Now in a problem like this one, it's pretty much the same amount of work to do it either way. It really doesn't matter. But I can run into problems like this next one. 24 25ths times 35 36. But if I were to multiply this out, 24 times 35 is 840, and 25 times 36 is 900, and I could reduce that. But that's big numbers, and I don't want to do that much reducing. But if I look at this, I see what can be reduced. 24 and 36 can both be divided by 6. Okay, 24 times divided by 6 would be 4. 36 divided by 6 would be 6. When you look at that, we still see we can reduce by 2 more, right? Here's 2 and 3. Could have divided by 12 right away, but we don't have to. If we use a smaller number, we can just keep reducing it. What else do we see can be reduced? 25 and 35 can be divided by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. And now we combine the counts. 2 times 7 is 14. And we combine the names. 5 times 3 is 15. We get 14 15ths. Any questions? Okay, now just like with our addition and subtraction, we're not going to spend a lot of time on multiplying simple fractions. We're going to jump right up to mixed numbers. Seven and 1/3 times 4 2/5. Multiplying mixed numbers is actually an extremely difficult process. In fact, I would be willing to bet if you went over here to the university and found 10 math majors and asked them how to multiply mixed numbers, I would bet none of them could do it correctly. So how do we do it? Well, we're going to cheat, and we're going to convert them into improper fractions. So 7 and 1/3 is going to become what as an improper fraction? 22, good. 4 and 2/5? 22/5. Now at this point, we could cross cancel if we were able to. In this problem, there's nothing that cross cancels, so we're not going to. There's nothing to do there. So then we go ahead and we multiply. 22 times 22 is 484. 3 times 5 is 15. Now here's the difficult part of this process, is we now have to reduce that back into a mixed number. So it is going to be 484 divided by 5. 5 does not go into 15, I should say. 15 does not go into 4. 15 does go into 48 3 times. That's 45. 3 left over, bring down to 4. 15 goes into 34 twice. 2 times 15 is 30. There's 4 left over. So it is 32 and 4/15. Anybody want to see how I'd multiply these out? Just for fun? Sure? Okay. You know, it's been a couple of years since somebody actually said okay to that. Usually is every year, somebody wanted to see it. In the last 2 years, people don't want to see it anymore. It's not as horrible as it sounds. It's just a lot to keep track of. So we're looking at 7 and 1/3 times 4 and 2/5. If I had like 23 times 42, this 2 here not only multiplies the 3, it has to multiply the 2, correct? Same thing happens here. The 2/5 has to multiply the 1/3. 2/5 times 1/3 is going to give me 2 over 15. But it also has to multiply the 7. How do I do 2/5? How do I do a fraction times a whole number? It becomes 7 over 1. It becomes a fraction by doing that. So 2 times 7 is 14. 5 times 1 is 5. So that is 2 4/5. Then I have to do by 4 times 1/3. So again, that's 4 over 1 times 1/3, which is 4 over 3. So 1 1/3. And then 4 times 7 is 28. Now I have a bunch of different fractions with a bunch of different denominators. I need to find the common denominator for all of them, and it appears to be 15. So the 2/15 isn't going to change. 4/15 becomes 12/15. 3/15 becomes, or 1/3 becomes 5/15. And then we have 2 and 12 makes 14. 5 is 19/15. So that's 1 4/15. So I'll keep the 4/15. Carry the 1. 1 and 2 is 3, plus 1 is 4, plus 8 is 12. So 2 carry the 1. 32 4/15. Exactly what I got up here. Personally, I'm probably sticking to the improper fractions. A little bit easier. But you can see here it can be done. And I actually work with smaller numbers. It's just finding the common denominator of 3 or 4 different fractions. It's the problem.
So then once you divide 44 divided by 15, you get 32.2666667. How do you put that to a fraction again on your calculator?
Okay, if you're on your calculator, good question. If you try to reduce this 484 divided by 15, you get that 32.2667. Here's what you can do. You can do this. Subtract 2. Or it's not 2, 32. 32 is the whole number. You subtract the whole number off, right?
Right.
And you're back to this 0.266667. Yeah. Multiply by, what's your denominator again? 15. 4/15. Now, what calculator do you have?
Yeah.
Okay. You have an ABC key on there?
Yeah. What
you can do on that calculator is you can just type in 484, press that ABC key, type in 15 and hit equals. It'll reduce it for you automatically. On the Sharp or the Casio, it's a key that just looks like that instead of an ABC key. If you have different keys, let me know and I'll help you find them later. Let's do one more multiplication together, and then I'll have you try one. So 5 1/4 times 3 and 3/8. So what do we start out with? So remember, we don't need common denominators to multiply. But we're going to change them into improper fractions. So 5 times 4 is 20, plus 1 is 21/4. This one's going to be 27/8. So now 21 times 27 is 567, correct? Yep. 4 times 8 is 32. And now if you have the calculator, you can reduce it on there, or I'll do it the long way. 32 goes into 56 once. 24 left over, bring down the 7. 32 goes into 247. 8 won't quite go, let's do 7. 7 times 2 is 14. 7 times 3 is 21, so 22. With 23 left over, so 17 and 23 36. What do you think? Better than sharp stick in the eye? For now. Okay. In your notes, I'm going to have you do 6 2/3 times 2 2/5. What are you going to get for the first one? 20 over 3. Okay, for the second one? 12/5. Okay. Then what are you going to do? You can cross cancel there. 20 and 5 will give us 1 and 4. 3 and 12 will give us 1 and 4. 4 times 4 is 16. Over 1 is just 16. That one worked out kind of convenient, didn't it? Okay, so next on our list is division. We've said before, when we multiply straight across. And division follows the same rules as multiplication. So if I have 12/25 divided by 4/5, can I just do 12 divided by 4 is 3, and 25 divided by 5 is 5? Does that work? Well, is that the right answer? Sure is. That is the right answer. Would that work every time? Actually, it would. But why don't we do it that way? Well, because we sometimes run into things like this. Not sometimes. Usually we run into things that look like this. If we try to divide straight across there, are we going to get nice, neat little answers? No, we're not. 3 divided by 2 is 1.5, and 4 divided by 3 is 1.333333. Not going to come out nice and neat and perfect like it did up top. What have we been taught to do for problems like that? To divide. The 3/4 doesn't change. What do we do the rest of it? Yeah, times, then we call it the reciprocal of this is what we call it. We flip it over, it's 3 over 2. And now we just multiply like any other multiplication. 3 times 3 is 9. 4 times 2 is 8, which is 1 and 1/8. Believe it or not, this process of multiplying by reciprocal comes from this. You always flip the one you're dividing by gets flipped. Let's look at how that comes about. 3/4 divided by 2/3. Well, once upon a time, before we define that concept of a reciprocal even, the way we would have done this, we would have looked at this second fraction, and as long as that fraction cannot be reduced in any way, which it can't, we would just do the numerator times the denominator. So it would be 2 times 3, which is 6. Now we're going to use that 6 to rename the first fraction. So 3 times 6 is 18. 4 times 6 is 24. Now if we divide by 2/3, 18 divided by 2 is 9. 24 divided by 3 is 8. We get 9/8, or 1 and 1/8. Exactly what we got down here. Well, how did we get from this to this? It still doesn't look similar. Well, at one point, somebody looked at this here and realized, hey, if we kind of stretch our order of operations a little bit, and we do this part here first. 6 divided by the 2/3. 6 divided by 2 is 3. 6 divided by 3 is 2. What we're going to get there is always going to be this fraction just flipped over. So they decided, hey, let's name that the reciprocal. Then we can change division to be just multiplying by the reciprocal. And there it is. So that multiplying by the reciprocal is really just a severe shortcut of a much longer process. All it is. Now, I don't know if any of you were taught the zigzag method or whatever they called it in your textbook. To divide, you multiply it at zigzag. 3 times 3 is 9. 4 times 2 is 8. Anybody taught that? Oh, good. Don't forget you ever saw it, because I absolutely hate that method. This is one of those gimmicks that causes a lot of mistakes. What's that? That's how you learn that zigzag? Okay. Yeah, it's a gimmick. But what all the zigzag is it's simulating this without actually flipping it over. Because here you're going to do 3 times 3. Here you're doing 3 times 3. You know, it's just it sets you up for a lot of mistakes. Because okay, you multiply at a diagonal, but then you got to remember to put it back up top. Because if it works for you, it works. I mean, feel free to keep using it. Because I see a lot of mistakes get made with that method. So if I have 5/8 divided by 1/5, can I cross cancel here? No, I can't, because it's division. I can only cross cancel in multiplication. Now this is going to change into multiplication. The 5/8 does not change. The first number never changes. It's the one we're dividing by becomes 5/1. So now it's 5 times 5 is 25. 8 times 1 is 8. That is 3 and 1/8 when you reduce it. If you're wondering, it's just 25 divided by 8 is 3 with 1 left over. So 3 and 1/8. Now you also might be wondering, how can we divide something and end up with an answer that's bigger than what we started with? Doesn't division make things smaller? Remember, we talked a little bit last week about division being repeated subtraction. As long as what we're dividing by is smaller than what we're starting with. 1/5 is smaller than 5/8. So we can subtract it from there. In fact, we can subtract it 3 times with a little bit left over. So forget about that whole idea of division making things smaller. Division is that repeated subtraction. Okay, we were getting short of time, so let's jump up to mixed numbers. Now it only makes sense if we're going to turn division into multiplication. That when we divide mixed numbers, we take the same strategy we did with multiplying, and that is to turn them into improper fractions. So what's this one going to become? 23. 5 times 4 is 20, plus 3 is 23. This one will be 19. 2 times 8 is 16, plus 3 is 19. Can I cross cancel there? No, it's still division right now. I have to make it multiplication yet. The 23 over 4 will not change. First fraction always stays the same. When it becomes times, this will be 8 over 19. Now now that it's multiplication, I can cross cancel the 4 and 8. Give me 1 and 2. 23 times 2 is 46. 1 times 19 is 19. That goes in there twice. That's 38. 8 left over. 2 and 8, 19. What do you think? Better than a sharp stick in the eye? Yep. Yep. Try this one in your notes quick. That's a 7 1/3, and that's supposed to be 8. 3 3/8. You could do 7, press the ABC key 1, ABC 3. That enters 7 1/3. Then just hit divide. Then 3, ABC, 3, ABC 8. That's 3 3/8. Hit equals, and it'll spit out the answer. So what's going to go up here? 22, and up here? 27. So we're going to keep this one the same. We never changed the first one. This one flips to be 8 over 27. Then what? We could Well, we can't reduce them. We're going to multiply. 22 times 8 is 76. 3 times 27. 81. So we get 2 and 14 over 81. Yes? Okay, well, we're running short of time here. In your little book, it's units 6, 7, 8, and 9. The odds again. Yep, 6, 7, 8, and 9. Do the last few minutes of class get started on those. Just order of operations. Yep. Yep, have a good one.
I might have to ask for help on these things sometime.
Oh, sure.
I don't know where it is I'm getting lost, but it's somewhere in the process of doing anything. Like I can do fractions,
Okay.
but somewhere in the process I'm just losing it.
No problem. Do you have the calculator?
I do not.
Okay. I would recommend if you started with fractions, pick up a TI-30.
Okay.
It'll be good help once we. It'll take us some time to teach how to do it, but we'll look over the fractions too, because it'd be nice to know how to do the fractions without it too. But
I don't know where it is, but I mean like you can find like when you times it.
Yep.
Say if you do like 20. Well, go up.